moving forward through 4.1. Now we're going to institute initial conditions with particular solutions. What all does that mean? Well, as we've been doing these indefinite integrals, we've been, adding a constant c at the end of every integration. Well, in this case now, we're going to actually have some sort of initial condition, based on time or things like that, that allow us to figure out what that constant originally was. This is really beneficial. You'll do a lot more of this in physics. You'll do a little bit more of this in DiffyQ, and you'll definitely do it in advanced calculus concepts. So understanding how to apply initial conditions is going to be very important for you guys. So make sure that you understand this concept down. We don't spend a lot of time in this unit on it, but it is used throughout math. All the engineering courses you're going to take or those sort of things will also incorporate that as well. So what we want to do in this example is we want to find the general solution and the particular solution. So remember, the general solution is the one that's going to just incorporate the plus c. The particular solution means we actually have an initial condition that allows us to find what c is. So in this case, it asks us to satisfy when f of 1 is 0. So the first part of all of these is we actually have to take the antiderivative, or take the integral. So the question says find the general solution of f prime of x equals 1 over x squared when x is greater than 0, obviously, so there's no division by 0, and find the particular solution that satisfies the initial condition f of 1 equals 0. So when we do this, f of x, right, that's the integral of 1 over x squared dx. Let's rewrite that integral as x to the minus 2. I think you guys can figure out the general solution. We've done enough examples throughout the section to be able to do that. So our general solution is negative 1 over x plus c. So now we're going to use our general solution to find the particular solution. So we're going to use what's given. F of 1 equals 0. So what does that really mean? That means we're substituting in 1 for x and 0 over here for f of x. So we're going to get 0 equals negative 1 divided by 1 plus c. So 0 equals negative 1 plus c, or c is 1. So we take that value of c and we plug it into our general equation. So we end up getting what? I didn't fill it out here correctly, but this should say f of x equals negative 1 over x plus c. That's the general. And then when we write this c right here, should say 1. So this should say f of x equals negative 1 over x plus 1. That would be the particular solution. So I got a little error on my notes there. I'll go back and adjust those and re-upload them. Okay, let's look at another one here. We want to solve the differential equation. We have when f prime of x is equal to 6x and f of 0 is equal to 8. So this is what we're going to have to integrate. This over here on the right hand side, the f of 0 equal 8, that's our initial conditions. Okay, so break that up. So now we have the integral of 6x dx. We should be able to do that now, right? This ends up being 6x squared over 2 plus c, and then we simplify this 6 over 2. So over here, our general solution is f of x equals 3x squared plus c. Now we have to use our initial conditions here, f of 0 equals 8, to get our c. So when we substitute that in, we're going to replace f with 8 and 0 in for our x value. When we do that, we get 3 times 0 squared plus c is equal to 8, or c equals 8. We put 8 in for c into our general solution. I did do this one correctly up here. So we replace the c with 8. So our particular solution in this case is f of x equals 3x squared plus 8. So if you see the difference between the general solution and the particular solution, the general solution has the plus c, and the particular solution is us finding what c is and substituting it in. I'm getting the exact or the particular equation because it's particular to those type of initial conditions. Okay? And we're going to move on to the next example in the next video.